Now that we have an application that, although being very simple, is functional and well architectured, let's use it as a playground to show some benefits and capabilities of our stack. Let's begin by creating another interface to our data processing logic. This time we want to access it through the command line, and we're going to use dry-cli to help us in that purpose. First of all, we create a Ruby executable within a new bin folder. The only thing that it needs to do is boot the CLI component of our application, which we still need to create. Remember, we have to add executable permissions to it. Let's use the code in our HTML interface to help in the boilerplate of the new component. We only need to do some renaming and we still have the core component as a dependency. Now let's create the file where we're going to define the command. As we said, we're going to use dry-cli to make things super easy. We're also going to lean on dry monads and dry schema, as we'll see in a moment. We're going to expose the calculation of the weight on another planet to the terminal, just like we did before through HTTP. The command is going to accept some arguments that we need to validate. We don't want to extract common behavior too soon. So for now we're going to define just the same schema that we defined in the HTML interface. dry-cli provides a DSL to automatically build help information for the command we create. We also specify the arguments it accepts. In the call method, we do the calculation. We need to sanitize the input and again we pattern match on the result to render an error message or the calculated weight. Lastly, we register it with a custom name. Let's try how it works. Let's completely change the scope and get back to WebPipe. WebPipe is a RAG application builder, so it would be sad if it didn't provide a way to reuse all the RAG middlewares that already exist out there. Fortunately, it does. We're going to use the RAG runtime middleware, which adds a response header with the time elapsed to process the request. We can check that this information is not present at the time in the response headers. To add the middleware to the show action, we need to require it and then we can make use of the use method. Again, it requires us to give it a name to the middleware step on top of specifying what needs to be applied. Let's reload the page and see that the information is available now. Let's get back to the show action class. In the case that it was a real application, there would be some plugs that we'd need to reuse in other actions within the HTML interface. Let's reflect a bit on what a plug operation is. An operation is just a function that takes a connection struct and returns a connection struct. Taking and returning the same data structure means that the result of composing a bunch of operations behave exactly the same as a single one. If we take two operations and connect the output of one to the input of the other, the result is another operation. Something similar happens when rack middlewares are considered from the perspective of a rack application. So, let's create a top webpipe class. We're going to extract here what we consider common behavior: the runtime middleware and how we treat parameters. We can then both use and plug the webpipe instance as a whole and check that everything keeps working. Otherwise, the compose method is a shortcut to compose both middlewares and plug operations at once. At this point in time, you might wonder why we keep using names to specify plug operations and middlewares. To begin with, it's useful as a description, but more importantly, it allows us to uniquely identify them. We can leverage that when it comes to testing purposes, where you could want to mock a heavy computation. However, let's play with it directly on the router. Remember that the container is taking care of the initialization of the show action. Initialization is the moment where we can inject custom operations and middlewares, so we need to do it manually now. Let's substitute the render step by a lambda where we just set hello world as a response. Now let's fool the scale and increase our weight. We can also inject custom middlewares. Let's substitute the runtime middleware with a version that just adds a kind of random header. To end with this series, let's showcase some ideas that we can leverage when testing webpipe applications. We're going to use rspec to add some tests to the HTML interface. As a starting point for the setup, we just need to boot the component in the spec helper file. There are two approaches that you can take to unit test a webpipe class. As it's just a rack application, you can interact with it in that way. Remember, we're using Hanami router and that it's automatically extracting the parameters from the URL. So we need to link with the show action through it. We're going to test that the response status is 404 when the planet is not known by the system. Rack provides a helper to create a mock environment, so we can use it to fake the URL that is being accessed. We call the router with the environment, which gets dispatched to the show action. And then we can assert the response status. Another approach is to unit test individual plug operations. Webpipe provides a test helper to allow us easily build a connection extract to fit them. We need to require Webpipe testing support module and include it in the test file. We grab the calculate plug operation. And use the buildCon method provided by the test support module to create a connection extract. The calculate plug makes some assumptions on the extract that we need to recreate. Essentially, that the parameters have been parsed and added to it. We can then apply the operation to get the new connection extract, on which we can make the assertion about the response status. Okay, this episode concludes our series. I hope you enjoyed and grasped the flexibility and simplicity that both Webpipe and the dry-RB ecosystem come up with. Please, come over to the discussion forum to share your thoughts about Webpipe, or leave a comment in this video. Remember that you can check out the final code for every chapter on this series in the GitHub repository. See you another time.